Hello dear students, in this video we can just see an example on the round robin. So in which the arrival time would be a same. I mean within the zero time limit. So all the processes have been just arrived. So consider this example in which we have a 4 processes who carries the burst time as 53, 17, 68 and 24. And the time quantum we have defined it as 20 milliseconds. We already know that what is a time quantum. So if we are just defining a time quantum, this is the maximum time in which each of the process could just run on a CPU time. So more than this they cannot be use the CPU, they will be preempted, the CPU will be preempted, it will be taken out and given to the next process. And assume all the processes have been arrived at time 0 seconds. Now we need to just show the Gantt chart for this problem. So let us just draw the Gantt chart for this. So this is already solved. I am just going to describe the solution over here. So let us just have a scheduling at time 0 because they have all ready in the ready queue at time 0 itself. So since it is just going to have in the order of their arrival, or in the if the arrival time is same, we could just go in the order of their identifiers. So let us just schedule the P1 for the amount of 20 milliseconds, or for the time duration of 20 milliseconds. So P1 will be just scheduled for 20 milliseconds. Out of 53, if it is done for 20 milliseconds, remaining time would be 33. So that will be put back into the ready queue. So the remaining time, or the P1 will be just done only for 20 milliseconds, and for the remaining time of execution, so it cannot be just continued because the time limit is only for 20 milliseconds, so that it could just run in the next round. So for the next round, the 33 is the burst time of P1. So P2, so next in the first queue is the P2. So P2 is having the burst time 17, so that P2 will be just can be just finished within the time quantum, because the time quantum is 20 and his burst time is 17. He could just finish within the time limit. So in that case he needs only 17 millisecond. From 20 second to 37, the P2 will be completing the job. So in this case we are not putting the P2 back to the queue because he is successfully completed within the single round, so that remaining time would be 0 for the next round. So next is P3, which is having a 68 as a burst time. Since the time quantum is 20 millisecond, this will be allowed only for 20 millisecond. So schedule P3 at 37 for 20 milliseconds. So from 37 to 57 it will be executed, and for the remaining execution it will be put back to the tail of the ready queue, so that 48 burst time will be just run in the next cycle or next round. So next process in the queue is P4, that is having a burst time 24. So he will be given the CPU only for 20 milliseconds. So from 57 till 20 seconds, that is till 77, P4 will be scheduled, and for the remaining execution he will be kept back in the tail of the queue, that is with the remaining burst time of 4. So now all the processes have got the CPU in the first round for 20 milliseconds. Now we need to continue for the next round of execution. In the next round we have a P1 with 33, P2 with the 0 burst time, P3 with the 48, and P4 with the 4 milliseconds. Now just keep on scheduling the CPU for only 20 milliseconds because time quantum is 20 seconds. So now for out of 33, P1 will be just allowed to use the CPU only for 20 milliseconds. So from 77, 20 milliseconds will be just given for P1, and he will be just done at 97. And then since there is a remaining burst time, so this is not allowed to continue, but it will be kept back in the ready queue for further execution in the next round. So the remaining time, that is 13, should be done in the next round. So next P2 is done. So next the process in the queue is P3 with the 48 burst time. So now we need to just allow P3 for 20 milliseconds. From 97 it takes 20 milliseconds. So 117, he will be just finishing the job in the second round. So if any remaining time, that would be just done in the next round. So P3 will be just get attached to the tail of the queue for the next round. So next in the second round, for the P4 is having only 4 burst time. So now from 117, so since he could successfully completed in within a 20 millisecond, he needs only 4 milliseconds. So from 117 till 121 the P4 will be completed, and he does not have any CPU burst time for the next round. His remaining time would be 0 for the third round. So now we have done we have processes all the processes in the second round. Now we need to just move to the third round and check is there any other processes left out. So we have the two processes where in which the first process is still having the 13 bus time, and one more process that is P3 which is still having a 28. So now again we need to just follow the order, give the CPU again for the P1 from the order. So since he needs only 13 out of 20 milliseconds, so P1 will be just scheduled. P1 will be just scheduled from 121 plus 13 units time, that is still 134. It's not 20 because he has only 13 milliseconds, so he could be just scheduled rescheduled at 121 and he could be finished at 134, and his remaining job to the next round would be 0. And in the third round, is there any process? Yes, we have P3 which is having a 28. So again P3 will be given 20 milliseconds, so P3 will be just given 20 seconds, that is from 134 to 154, and remaining 8 burst time will be just continued in the next round, and we do not have any other process in the third round. So now move to the next round. In the next round, P1 is done, P2 is done, P3 is having the burst time 8 millisecond, and P4 is done. So only the one process that is left out, so that will be just given a CPU for 20 millisecond. Since it is having only 8, so he could just need only 8 milliseconds from 154 to 168, and he can be successfully completed within that. So for this Gantt chart, you could just draw, we could just calculate what is the completion time, what would be the TAT, and what would be the waiting time. Thank you.